Hi, welcome to our continued focus on math and English language learners and the things that we should recognize as teachers that might be challenges or could end up acting as resources for our English language learners. So last time we talked about the language of math, and what we're focused on now is the culture of math. And what I want you to know is that I've known for a long time that culture was very important for mathematics, and I've picked up a little bit here and there. I've attended some conference sessions, I've read a few things, but what I'm going to share with you today is the clearest I've ever been on what the impact of culture is around mathematics. And my ideas have changed a little bit. So I'm hoping that wherever you are on that understanding already, that this lecture takes you farther down that pathway, and that the readings and the links that I send you to afterwards increase that as well. So what I've called today's lecture is Culture and Math, Some Considerations. And the place I want to begin is simply with the idea that math is cultural. And if you were raised in the U.S. in a typical school system, as I was, that might be a little bit of a foreign idea. Sometimes when we get to university or sometimes in high school, our teachers, our professors might have mentioned, oh, this idea came from the Babylonians, or this idea came from the Greeks, that kind of thing. But for the most part, we don't tend to talk about where ideas came from and how they were kind of embedded in the cultural needs and the cultural context that they were born in. And so let's just start with this idea that math is cultural. A researcher around math in 1988, he said that people around the world have used mathematics to count, measure, design, locate, explain, and play. And I love that list. That comes from Bishop. He wrote that in 1988. I love that list of verbs because those are cultural activities, right? The way we count, the way we play, the way all of those things, those are culturally embedded activities. And you bring numbers in, and suddenly you can see, of course, people around the world count in different ways and measure in different ways and play with numbers in different ways, right? And how they're used. And so once you kind of start to reorient yourself, instead of thinking of math as just kind of this deculturized vacuum, you walk into a classroom and someone puts math notation all over the board. You write it down, study for a test, and that's all it is. Once you begin to realize it's all about thinking through numbers and thinking through measurement, and then you realize, oh, I see, there's a lot of room for culture to kind of shape that, the way that people think with numbers. So I think that's a really good place to begin. And I think it also helps us start to see, of course, if math is a verb, and if math is a cultural practice, then of course there would be drastically different ways to think through math and use math and math as a verb around the world. And so that's a really good orientation. And as I talk to you about it today, this is the clearest I've ever been in looking at some current research that is absolutely the case. So the thing is that we often, whether we're teaching first grade math or high school math or whatever it is that we're teaching, we often forget that math is cultural. That the way that people have thought about and needed and used mathematics around the world is quite different. Instead, we often presented, and I know it was presented this way as I was growing up, and I know that's before Common Core. Common Core, I think, is making some important steps in this direction. But when I was growing up, we were taught math as if it was in a vacuum. But when we go back to this idea that math is cultural, you should see that something was going on for me as I was growing up in my math classes, and that is, since math has to be cultural, but I was being taught it as if it was not cultural, that meant that I was being taught the ways that mainstream U.S. culture thinks through and uses and needs and plays with numbers, right? But it was being presented as if this is the way it is, when really it was just, this is the way that mainstream culture in one country thinks through and plays with numbers and needs numbers. And so we often in our math teaching forget that the students in our classroom may have very different experiences with numbers. They may have used numbers in drastically different ways. They may have seen their parents and their families and their communities use numbers for very different purposes and in very different ways. And the way that they arrive at measurements or arrive at certain math functions might look quite different. And their own purposes, the students' own purposes for using math might be quite different from each other and from mainstream U.S. culture math. Now, how do we fix that? Well, we're going to talk about that a little bit with pedagogy in the next lecture. But one thing I can say is there's one thing I like about Common Core is that there is room for students to come to bring in their own personal experiences, their own personal kind of way of making sense of things, their own way of thinking through what's a way to come up with the answer to this problem. So whenever we create some space for difference, that's when we're creating space for some of that cultural kind of perspective to come in. It doesn't fix the entire problem, but it's a start. Okay. So I want to talk about something else. Sometimes we do attempt to include culture in math, but we tend to do it in a very shallow way. So what do I mean by that? So we include culture in a shallow way by, for example, taking a word problem that's about, to go back to our last lecture about fruit leathers, and wherever it says fruit leather, putting in tortilla, or putting in rice, or putting in some other kind of shallow cultural artifact. And so I think the danger of that, I don't think that's a problem, except if a teacher says to himself or herself, well, I have included culture, and that's the way that they're kind of doing it, then the problem is they're not really doing it. Because if we go back to what I mean by math is cultural, math is actually ways of moving through the world to measure, to identify, to play, to come up with an answer, to calculate, all of that. And if all we're doing is changing the nouns or changing the names, so instead of John, it's Johann or Jaime or whatever, then we're not really bringing in cultural ways of thinking about math. And so we really need to be reaching for something else. We really need to be, if you're teaching in a classroom and you've got students, some who are mainstream students, and so their families speak English at home, and they don't really identify with anything other than mainstream U.S. culture, and then you've got students from two other cultures in the classroom. Really, I think it's our responsibility to learn from those families, how do they use math? How is math used in their community? what are some traditional practices that the family or the community still identifies with that use math? For example, there are many cultures from Central America for which braiding or weaving are very important practices, or for big collections of people coming up with exactly the right number of tortillas or other amounts of food. How do they arrive at that? Math is involved. How is it involved? So I think one thing we can do is honor this idea that math is cultural by, let's say you're teaching 4th grade, when you have your time to talk with parents, finding out about how math comes alive for them. How do they use math? And how has their community used math? And what are some traditional practices that they still identify with that involve math? Learn about those and see if those don't give you some ways to help students at the very least connect with the math content, the math functions that you are teaching. But it's very possible that the content itself will start to help students to better understand the math of their community as well. So, anyways, what I hope that did for you is that it helped you to start thinking through how we can really bring culture into our math teaching, how we can connect communities to our math teaching, and how we can really help students connect with the math content. There's 3 links, besides some chapters that I want you to read in your math textbook, Teaching Math to English Language Learners, and you'll see those on Canvas. There's also a few links. And one of them is actually, it's the introduction to a book. And the book is looking at how to bring math alive for English language learners. Now, this introduction kind of, in slightly different ways, and probably even better than I just did, really grounds itself in this idea that math is cultural. So I want you to be exposed to that, hear it from someone slightly different. But then the rest of that chapter, where it heads is to talk about the projects that are covered in the book. And as you look through those projects, look at how they are not simply bringing in math in a shallow way, but they are really attempting to get at the thinking through math that occurs in different cultures and to bring that into the classroom. So I'm hoping that as you read through those examples, anything that's not quite clear for you about the difference between math as cultural and then just bringing in different names or different nouns into your word problems, that'll become really clear for you. It's a really great collection of little examples there. Okay, so I'm hoping that you're convinced, because I am now, that math is a truly cultural practice and that we really need to learn about our English language learners' backgrounds and families and communities' practices. Let's talk about math notation. I briefly touched on this when we talked about language, and math notation, because it is a kind of language, it kind of belongs in both, right? Language and talking about culture. But let's take a look through here. One thing that students who have, especially those who have started their education in a different culture, they've started their education in a different country, different educational school system, it is very likely that the way that they write their 1s and their 7s will be difficult for someone like me who's grown up in mainstream U.S. culture to tell the difference. And so, so that would be something that you'd want to work on, be aware of, obviously without kind of talking to your students about it, how to make it clear, how when they write their 1s and their 7s to make it clear to someone who's grown up in this culture which one they mean. Students could, for example, provide the correct answer to a problem and it's counted incorrect because the number is read differently. So that is something that should absorb a little bit of your time with your student if they experience that difference with U.S. Math writing. Another thing, and I think I talked about this with the language lecture, is that in a lot of cultures where we would put a comma, they would place a decimal point, and where we would place a decimal point, they would put a comma. So for example, the number, let's come up with a number here. How about 26.55? So what I mean by this number is the whole number of 26, and then 55 hundredths. So this is a fraction here, 55 hundredths. And I put a decimal point. But in many places around the world, many places actually outnumbering the US, this would be a comma. And vice versa. So where we would place a comma, a decimal point would be placed. And so this is something you would want to work on with students if they write their numbers this way, to make sure that they understand how it's done in typical mainstream US culture and help them make that change. Because outside of your classroom, even if you're able to decipher the difference, they will eventually encounter someone who won't. And there might be big repercussions, whether that's with a bill they're paying or their bank account or a big exam that matters greatly for their work and maybe their studies. So make sure that they're clear on how that is done. Another thing I wanted to highlight is how we show division. So many functions, math functions around the world, are shown in drastically different ways. But the one that I think shows up the most with drastically different options for how the work is shown is around division. So what I have here, I have for point A, I have the way I was taught to do division, long division. If I want to divide the number 1,576 by the number 75, I would write the 75 on the left, put this interesting kind of bracket, kind of curves in right here, and put the number that's being divided into in there. And then what I do is I start from the left side. As soon as 75 will go into part of this, I write the number of times 75 will go in. 2 times 75, I write that number. It has a remainder of 7. I bring down any remainder number, 76. 75 will go into 76 one time. 76 minus 75, there's 1 left over. And depending on what kind of math you are teaching or what you want your students to do, you might have them simply writing what the remainder is, or you may have them add to infinity, doing that division to come up with exactly what that decimal point is of how many times 75 will go into 1,576. That's the way I was taught to do math. It's very likely it's the way you were taught to show division as well. Now, here is one of many ways that division can be shown around the world. So, same problem, but notice that the numbers 75 and 176, they're now on opposite sides. And I don't even know what this means. I found this online, and I'm not even sure how exactly this works, but look at this. This is where the answer is. It arrives at the same answer, but if you were a teacher working with students who had begun their educations in another educational system, and they arrived at the correct answer, you may not even recognize that they meant that as the answer. And if you are requiring that math work be shown, it's very possible that the student would get points off for not showing the work. Because I was taught whenever I do division, always show all the steps of the division, just like I've done here. Around the world, that's not always the case. When the division is fairly simple, people don't show it. And so they only show the kind of the bigger parts, the more difficult mental operations are shown. And so this is one of many different ways that division can be carried out. But I wanted you just to kind of get a sense that math operations are shown in very different ways around the world. And so it's very likely that you'll encounter that. Even if you are working with a student who did not begin their education in another country, but their parents are helping them at home. They're educating them at home. And so the parents, of course, would reflect what it is that they are showing. One thing to keep in mind about this, if this is working for the student, and if you are not required by Common Core, you're not required by the assessments that the students are held accountable for to show work in this way, if it's working, I wouldn't change it. So if it's working, stick with it. And if it's not, then attempt to move the student to the more mainstream US way of doing it. So something to think about. That would be maybe one thing that you wouldn't suggest that the student change the way that they're doing that. Another thing I wanted to highlight is reducing fractions. And we in the US, because there is, and I think it's a good thing, there's a focus on making a math problem into a real life application. We often reduce fractions. So for example, if you have your students doing a math problem around how many, if a cake has 16 pieces and you're having a party for this number of people, how many cakes do you need to have if each cake has a certain number of pieces? And so when students are doing that work, they would come up with a fraction. But when we, especially with word problems, we expect usually to come up with a number that you could tell the bakery, I need 3 cakes, or I need 4 cakes, that kind of thing. So we don't hand them a large fraction and let them figure out the math. We do that reducing ourselves so that we can say we need 4 cakes, we need 5 cakes, we need 2 cakes. And reducing fractions is something that isn't done around a lot of the world. And so it's very likely that that might be a different way of expressing an answer that your students are experiencing in your classroom. So if you see some confusion about that, and maybe even some reluctance, that's where it would be coming from. So something to know about, something to think about it. It might be a teachable moment for you and the student to talk about why in the US we think it's important to reduce those fractions. Okay. One thing I wanted to say about math notation, I found just a lovely little, I think it's 2 pages of an overview that was created for teachers in Boston around working with students who are English language learners. And I think actually it's also, this 2-pager is written not only for teachers, but it's also written for adult learners who might be experiencing some problems expressing mathematical concepts in the US. And so I've included that. I think I've called it something like the notation of math or cultural notation of math, something like that. But you'll see these ideas coming up again. But it's just a really nice list. It might even be something you want to hold on to for when you're teaching and probably when you're talking to other teachers about how to think about the culture of math and how culture is in your classroom with mathematics, whether you realize it or not, including through notation. And the last thing I want to say about math in culture is for us, for example, in the Spokane region, many of our English language learners come to us as refugees. And what that often means is that they began their education in a refugee camp school. Now, our schools in the US have trouble coming up with enough resources. I'm sure it's not much of a leap to realize that a refugee camp school is not going to have much, and that's going to include not going to have much paper. So around a lot of schools in the world that do not have the resources that we have, it is thought of as part of thinking in a mathematical way is to be able to do mathematics problems in your head. And so it is very likely that if you have, for example, newly arrived students from a refugee camp, that they will be unfamiliar with the idea of writing out a math problem. Or if the way they learned to do a math problem was their teacher demonstrated it, but then they were expected to do it in their head because there wasn't anything to write with, they may be awkward at showing it to you, even though they can come up with the correct answer. So if you experience some reluctance, confusion on expressing something mathematically on paper, this may be the source of part of that confusion. Now, there has been, in the last 15 years, I've seen a big focus in math in K through 12 at students showing their work. And so within my career time, I've seen students be only penalized if they have an incorrect answer, and now we're in a place where if they can't explain how they got the answer, if they can't show that work, then they get dinged as well. And possibly sometimes that's the entire point system, is whether or not you can show it. So you can see we're on a collision course here if students haven't learned to express that work. If you're in a situation, and you probably will be, where students, at least in certain grades around certain concepts, must be able to show their work, work with the student to find a system that works for them. There's, like I mentioned, a great piece about Common Core is this new focus on students finding their own kind of personal way of thinking through the math, their own personal way of thinking through a math function, what they visualize in their head. And so I think that's a good thing, and I think it gives you some room as a teacher to find a way that your student can express that in a way that makes sense to that student. Okay. So as I mentioned, one thing that I have waiting for you after this lecture is you have a few chapters in your Math and English Language Learners book. What I'd like you to be doing with those chapters is looking for any additional information or even deepening information I've expressed around what culture has to do with math. So be kind of deepening that understanding. I've also already mentioned that you've got a short, very brief chapter it's an introduction to a textbook that looks at deep cultural ways to bring math into your classroom. I've mentioned that there's a 2-page handout meant for newly arrived English language learners and their teachers in Boston, and it goes over some of these notation issues. Go ahead and look at that. But there's another thing too that I want you to see, and I just found it this week. And it's a research article. It's huge. Okay, I don't want to scare you. I'm not asking you to read all of it, but it really is huge. And it's, for me, I love the way culture impacts things. And since I'm a teacher, I love to see how other teachers do things. What this study is that I've included in your links is what the findings were by getting into 7 countries' math teaching 8th grade classrooms to see what are the teachers doing. And so it's 8th grade math across the world, 7 different countries, although I want you to notice that these 7 countries are pretty resource rich compared to the rest of the world. There's I think, the US, there's Hong Kong, there's, I think, Britain, for example. And so I don't in any way want you to think that this is truly a spectrum of what's really going on, because when you think about what's going on in refugee camp schools, that's got to vary greatly from the kinds of things that show up in this study. But still, it's an interesting little look at how math teaching is different, and it might start to get you to think about the differences that your students might have experienced. So the article is long. I've got some pages that I'm suggesting. If you look at the link, you'll see there are pages that I'm suggesting you look at. And those pages are the part of the findings where they say how much time, how much teacher talk was there in the US classroom, how much time was there for individual work. And so it goes from country to country, about a page and a half each. What did they find? And it might get you thinking about how we differ around the world, even in places that aren't so different from the US. How do we differ around our math teaching? So another great place to get some traction there. Okay, I'm hoping that you have a sense of math as a verb, math as an important cultural piece in a way now that you didn't at the beginning of the lecture. Okay, enjoy taking a look at those links that I placed there. I hope that you learn from the chapters that we read, and I will see you online in our discussion.